Hi, today we're going to talk about what is a function. So a function is a special kind of relation. Well, what's a relation? A relation is a set of ordered pairs. A coordinate, a point, um, something represented with x and y. A function is a special type of relation. Um, a function for every x value, every beginning half of each coordinate, it pairs up with only one y value. And we'll see a little more as we go on. So, set of ordered pairs. A set means a group, something that belongs together. Here are three coordinates. These three coordinates, it's always x, comma, y, x, comma, y, x, y. Always that order. Now, I can rewrite this information in multiple ways. I'm going to take this, I could put it into a table. So table, I want to label the top, x and y, my first coordinate, 1, 2. Cool, let's put them in, 1 and 2. Next one, -5 and 3. Nothing special here, and 0, -4. Good. I could then take this information, I could also put it on a graph. So when we graph, we always move left and right with the x, and then up and down with the y. So I want to go to the right 1 and up 2. I want to go backwards 5 spots. I want to go up 3. And lastly, I want to go left and right 0, but then down 4. Um, so set of points, take those points. I could put them on a table. I could take that table and turn it into a graph. Now, what is a mapping diagram? Mapping diagram is almost essentially the same thing. It's just a fourth way of rewriting the same information. So we need a title up here. We'll call that x, call that y. I'm going to say 1, -5, 0, 2, 3, -4. So again, almost like I didn't do anything. The only difference with the mapping is I know that 1 and 2 are paired up. I know that 1 and 2 are paired up. I want to say what's paired up. 1 goes to 2. -5 goes to 3. 0 goes to -4. So there's an arrow going, this is my pair, and they hold on to each other. That's a mapping diagram. All of these are functions. Each x value, 1, -5, and 0, pairs up with exactly one y value, one answer. Now, there's other terms that we can use instead of x and y. X and y are good. X and y aren't always this, aren't everything that we're going to see. You might come across something like input or output. Usually, we input something into the x value and we get an output as our answer for the y. We could have domain and range. Domain is another name for all of your x values, 1, -5, and 0. Range is the name of all your y values, 2, 3, and -4. You may also see something called independent and dependent. So independent, free range, you can do whatever you want. Usually when we have an equation, we can put any number in for x, and then we come up with an answer of y. So our answer depends on what we input. So here's our different types of answers. Now, with all that, we also have a couple different ways of describing what's going on. And usually we get that with graphs. So two terms that come to mind, discrete and continuous. If you see a discrete graph, it usually just means we have a series of coordinates. They're not connected to anything. They're just points. It's kind of like a scatter plot. You don't connect the dots. They're just different individual coordinates. When they're not connected, it's discrete. This graph over here would be discrete. There's nothing connecting them. However, something that is an actual line, an equation, this is something called continuous, because in between every coordinate you have there, there's another coordinate squeezed in. There's no blank spaces on that line. And again, to get the line, you have to write an equation. So instead of just saying what is a function, you could write them as ordered paired table graph mapping. You could also add an equation to the group to tell you what is a function. Every one of these would be a function, and that is functions.